Well, hello everyone. Happy Thursday. Welcome to another episode of Cloud Foundry Weekly, episode 48. As you may have noticed, our good friend Nikki is not here this week. He's off traveling. So I'm just flying solo, but we do have a special great guest to bring on. We're going to be continuing our coverage of Zero to Hero with Spring AI. I'm going to go ahead and bring Adib back on the show and we'll get started here. Hello, welcome Adib. How you doing?
I'm doing very well. How about you?
Oh, not too bad. We had a brief moment of warm weather, and now it's kind of cold and snowy here again in Cincinnati. But uh, maybe we'll get spring here in a little bit.
Yeah, we did. I live in Toronto, and it used to look like the North Wall from Game of Thrones with a lot of ice and snow. I just
Yeah,
look outside my window and I see snow falling again.
yeah,
Maybe we'll get some spring weather soon. I'm looking forward to it.
yeah. We'll get out of this winter eventually. It's definitely been a tough one. But yeah, I mean, I guess I'm thrilled that you're back. If we look back to episode, oh boy, I think it's episode 26. Yeah, episode 26. So at least 6 months ago, you did the first part of the series of kind of giving just intro or kind of zero to hero, getting started with Spring AI and all the kind of cool stuff you could do with Spring AI. So yeah, I mean, we're here. I think we really just kind of got started. If I remember, I kind of rewatched the show early this morning, and kind of ended we're near around the concept of embeddings. We hadn't really gotten fully into RAG or retrieval augmented generation, things of that nature. So I know you have kind of full coursework that you could probably go on for many hours here, but I guess without further ado, kind of love to have you get started wherever you want to pick up and go from there.
Yeah, I think what I'll do is, I think the approach we were taking is one of like, hey, it's about learning some critical concepts as a developer when it comes to AI. And when it comes to building AI applications, you're probably going to run into RAG and retrieval augmented generation, which requires you to understand the concept of embeddings, and that's kind of a critical building block skill on the way. So what I want to do today is start by revisiting the idea of what's an embedding, building all the way up to what the RAG pattern is, and then if we have enough time, we'll look at a little bit about how to build some AI agents and some of the agent patterns with a fun little application.
That sounds excellent.
Yeah, yeah. So I guess I can share my screen and we can
get your screen on here, and then let me get our let's see, we'll get our view so we can get a little bit closer to the screen. But yeah, where are we? We're looking at your IDE here.
Yes. Yes, you are looking definitely at my IDE with some code. So this is the project that we used last time. Yesterday, I took some time out to upgrade the project. So it's now on the latest version of Spring AI. So hopefully all my samples still work. If not, we're going to be doing some live debugging.
So I mean, always good to keep your code up to date, I suppose.
Yeah, that's right. Just before we started, I updated everything on my on my IDE, and I'm looking up here. I'm like, my Docker desktop is out of date. I need to update it. So I'll wait till after this session.
Yeah, I appreciate that.
Yeah. But like, just to remind people what we're looking at in terms of the project itself. So the code for this is available online. So if I do git remote -v here, you'll be able to see the URL where this is located. And
put that in the chat too.
Yeah. And then the way the project itself is organized, it's organized into two parts: components and applications. So one of the values of Spring AI is that you can write the same code and it works regardless of the provider. And so what you see here under applications are very, very small, tiny apps where you just have a Spring Boot shell application to launch something. What's different about them is in the README files, you'll have like a dependency, for example, on, in this case, Vertex. If I go to the OpenAI one here, you'll see it's got a dependency on OpenAI. And so the idea is that the interesting code is not located under applications. The interesting code is under components. And that speaks to the portability of the code that you write. And so the way it's organized is the APIs project is where you can learn how to use the Spring AI APIs for various things. So just looking at this example here, if you want to learn how to use the chat APIs, you would look under the chat project, and then you would find that it's nicely organized for you in a numerical order so that you could follow along and like experiment and gradually step by step learn the concept. And then under the patterns section is where you can see some common patterns, AI application patterns people implement, like retrieval augmented generation, chat memory. Maybe you're building a chain of thought agent or a self-reflection agent or like stuff to prompt. So if you're looking for the patterns, you look under the patterns folder. If you're looking to learn to use a Spring AI API, you look under the APIs folder. So each of these projects will also, we'll start here at the embedding one. You'll also find that the way that the project is organized is that you write Spring Boot controllers. So if I'm wanting to review the embedding, how we do embeddings, you'll notice it's a REST controller. It's operating on this embed 01 URL. And if I send a request to text, it's going to execute this code right here. So the idea is you run the application. Like in this case here, I'm currently running the OpenAI application, and I can send it requests. Just to make it easier for folks to know, like, hey, where do I send the request to? If you happen to be using IntelliJ, it has this like HTTP client. So you can see here embedding request.http. So I'm able to just press the play button. Now it's going to send an HTTP request to that application, and we can see the response right here. So this is going to allow us to hopefully just only focus on the concepts and not have to worry too much about like a lot of the underlying details. And for the audience members, my goal is to have you walk away with understanding the concepts, how to do the concepts in Spring, how Spring AI helps implement the concepts and the patterns. But I fully understand you're going to have to do a lot of reading afterwards. So hopefully I just make it easier for you to continue learning on your own. Okay. If there are any questions, I guess you'll ask me whatever people are asking in the chat, so I can just laser.
Yes. Okay. Yeah. And if for those watching live, as mentioned, we have a live chat. So if you have questions, let us know. We can address it. Shout out to Keith for watching. Always great to see you. And and then I'll also be toggling our views up in kind of. You may see the screen go full screen, just so obviously Adib might start talking about something kind of below where our faces are. So if you see us disappear, we'll be back. But I just want to make sure that what he's talking about gets covered in the screen. So I'll do my best to help navigate.
I mean, is it possible to move because the console window where the output will be is kind of where our images are right now? Perfect. Thank you. Okay.
So we could do that. Just if maybe could you zoom in a little more then, perhaps?
I can totally make my fonts a bit bigger.
Yeah. Just want to make sure that might work too.
Yeah, that's no problem.
Yeah, this is probably a better view. I played last. I started doing the other week because I played last week's episode on my TV, and I was like, oh boy, I couldn't quite read the screen in this format. So hopefully, if you're having trouble reading the screen, let us know. It looks great on my actual monitor screen right now, so I think we'll be okay. Shout out to Nevin, great to see you.
All right.
Yeah.
So let's go through with this one here. So first of all, we want to talk about with AI, everybody thinks about chat models, but really chat models have a lot of, they're not the only type of model. A really critical type of model is called an embedding model.
Right.
And so we want to understand this concept of what is an embedding. An embedding is basically a long list of numbers And so you can see within Spring AI, we have an abstraction called an embedding model. And if I go to that, it'll tell you like, you can give me some text. And I will give you back an array of floating point numbers. Let's actually think about what this really means. So let's see an example here. If I send a request to this embed 01 text, I'm going to take the text hello world and return a bunch of values. So if I go here, you can see I scroll up. Oh my goodness, that is a lot of numbers.
Right.
Well, I don't want to count these. So I actually, oops. I don't need to get blame here.
Okay.
I do have another option here for dimensions, which is simply just going to say how many numbers were in this array that were returned. So let's actually ask that. And it looks like there are 1,536 numbers that were returned. So I gave it the text hello world and gave me back 1,536 numbers. And
that's I guess these this dimension thing is somewhat important, right? When you're trying to store these in the data store, some type.
Yeah, you're gonna have to store it. So different embedding models will give you a different number of dimensions. But the important thing is, what do these numbers mean?
Right.
The answer is nobody knows. Not me. These numbers mean something to the AI model. They don't mean anything to the human. Okay. So the best way to think about what these numbers are is like this. Let's play a scenario. Nick, you're a fan of computer hardware, right?
Sure, of course.
All right. So let's say you're evaluating some GPUs. Can you tell me some of the factors that you would use to evaluate the GPUs?
Like the amount of VRAM in a GPU, perhaps.
Okay, hold on. I need a scratch file first, because what I'm going to do is I'm going to like make a fake concept of an embedding. Going to be GPU evaluation embedding. Okay.
I mean, this is so apropos as the Radeon 9070 XT launched today too, as well.
Is it? Okay.
Yeah.
So we'll just do like a text scratch file. Okay. So these are the dimensions for GPU evaluation. Okay, that's more. Okay, so what's one thing you look at? You said VRAM, right?
Yeah, the amount of VRAM.
The amount of VRAM. Okay. All right, give me another dimension.
The cost, I guess, would be.
Okay, cost. Yeah. Okay. What's another one?
Availability, is that too?
Yeah. So we'll call
it on the shelves anywhere.
Lead time, when can I have it by? Right.
Yes.
All right, and what's another option?
Form factor, how many PCIe slots it takes up, perhaps?
PCI slots. Okay, I think we have enough things. So now I'm going to make an embedding vector for GPUs. So I'm going to say, give me a number for VRAM.
24 gig or 24. Okay.
I just say 24 because it's just a vector. It's only numbers, right?
Yeah.
So I'm going to write down what those numbers are. Okay, and what's the cost?
Probably about $1,500.
Okay, so $1,500. Okay. Yep. When can I get it?
3 weeks.
Okay, so I'm going to say 21. That's 21 days, right?
Okay.
And how many PCI slots?
3.
Okay. So what I've done here is I've captured attributes of a GPU using a vector, which is a set of numbers, but those numbers correspond to something, some attribute, right? Some dimension. So I've decided that this 4-dimensional vector, okay, is got amount of RAM, cost. When can I have it by in days, right? You can say in days, cost in, I can say in dollars, and VRAM in gigabytes. And so if you just see these numbers by themselves, you're like, what do they mean? I have no idea. This could be the weather. This could be like somebody's math homework. This could be whatever it is. So when we look at these numbers here, okay, we know there are 1,536 dimensions, but we don't know what those dimensions are. We don't know that this 0.01 blah, blah, blah means something.
Right.
And that's what's the kind of the hard part to grasp for a lot of folks is that these numbers mean something to the model, but it's okay that they don't mean anything to you, the human.
Mm-hmm.
Because we're not going to interpret, like if I'm trying to interpret this one here, it's important for me to know that the $1,500 is $1,500, right? Whereas this number by itself really means nothing. So what we want to do is we want to actually use these vectors to compare with each other as opposed to try to understand what a particular dimension means. All right, so let's continue on here then with what can we do with it now that we know what the idea is. What can we do with a vector? Okay, so first, what I'm going to do here is we can use it to calculate similarity. So I'm gonna run this, and then let's see the output, and then we'll learn something really important. So in this case, I'm not using any accelerators or anything, so it will take a little bit of time. Okay, so what's happening here is I've got a set of words like man and man, man and woman, man and dirt, king and queen, queen and queen in French, queen in Arabic, banana and car. Like these are just a bunch of words. I'm trying to find words that have no relationship with each other. Right. For each of these words, what am I doing here in this similarity calculation? I'm taking the word passed in A and I calculate its embedding. I take the word that comes in B and I calculate its embedding. Now I have two vectors with 1,536 numbers. And then one of the things I want to know is how close in meaning are those two embeddings. And that's where we do a calculation called cosine similarity. Oh, wow, that's reminding you of math and high school math and whatever.
Yeah.
The point is, the formula here is irrelevant. You don't need to know what the formula is. What you need to know is that I give it two vectors, and it gives me back a single value, a score. So, and that is what you are seeing here. So if we look at this, the output from this example is I see that the word man and man, when I calculate the similarity, it gives me a score of 1.0.
Right.
When I calculate king and queen, I get a score of 0.9519, blah, 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 right?
Mm-hmm.
I calculate man and woman, I got 0.9023. So what's happening is it's actually returning them from a score sorted in from highest score to lowest score. And the idea is if you get a score of 1, they are identical. Like they have exactly the same meaning, right?
Mm-hmm. Mm-hmm.
If you get a score of 0.9, well, what does that mean? I don't know what it means. All it means is that a score of 0.9519 is closer in meaning than 0.9023, right?
Mm-hmm.
So if you look at king and queen, man and woman, they're like, kind of like you can see some relationships. So if you're looking like what are these 1,500 dimensions? Well, maybe some of the dimensions mean, it's human, gender, societal role, or something like this. But the point is, when you look at all the dimensions of these, you are able to see that these two are fairly close to each other.
Right. Yeah.
Okay? It's certainly closer than other stuff. So if you look at stuff that looks happy and joyful, that wasn't quite as close as like man and woman.
Mm-hmm.
But you can see that they're both human emotions. They both kind of mean the same thing. But then when you look at happy and sad, right, you'll notice like something very interesting. It's very, very close, like 0.88, 0.86. It's kind of pretty close, but I thought happy and sad were the opposite. Yes, on some dimension they're the opposite, but on many other dimensions they're the same, like they're human emotions, right?
Right. Yeah.
Okay. And so the interesting part is what happens if you start looking at things like the word queen and a translation of that word to a different language. You'll notice that, like, wow, these are pretty close. Like queen and queen in Arabic, queen in French are like kind of scoring fairly close to each other.
Very close. Yeah.
And like sometimes if you have like in theory, if you have an embedding model that's trained on multiple languages and all of that, you may in fact get numbers that are fairly close to queen and queen. Like it should have been closer to 1 because it's the same thing, right?
Right.
You You see where I'm going with that?
Yeah.
So the main kind of concept that for people to understand is that the purpose of an embedding is to take some input, convert it into a long list of numbers,
Mm-hmm.
and then we're able to compute a similarity score between two different vectors, and now will tell us how close two different things are in meaning.
Right. Yeah, and this is useful for these vectors are how LLMs process meaning, essentially.
Right. Within like, yeah, usually when you generally speaking, if you're sending an LLM like a question, a prompt, it'll actually convert it into tokens, and the tokens get like turned into vectors, and then it does a whole lot of linear algebra math, and then it spits out an answer, right? But in this context, the interaction with the embedding model was to just to give me back the numbers that correspond to the input. Okay. So to illustrate like a more interesting example, we're going to look at how we're doing a semantic search. So here I have 25 motivational quotes. Okay. Like, education is the most powerful weapon which you can use to change the world, right? No act of kindness, no matter how small, is ever wasted, right? The best way to find yourself is to lose yourself in the service of others, right? There's no substitute for hard work, blah, 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 okay? So now what I'd like to be able to do is I would like to be able to make a request, and I would like the request to be something like, I'm looking for a motivational quote to encourage people to donate to the Cancer Foundation, Cancer Research Foundation. Okay, so if I copy this, let's go here to the terminal, and let's actually send a request. I would like to get the top 3 most quotes that are appropriate for the input of donate to the Cancer Foundation.
Right.
And you can see here it says carry out a random act of kindness with no exception of reward, right? Single act of kindness throws out roots in all directions, and no one has ever become poor by giving.
Yeah.
You can see that it didn't pick like something like there's no substitute for hard work.
Yeah, that probably wouldn't be quite
that wouldn't be
appropriate. Yeah,
right. That wouldn't be appropriate.
Or the spontaneous combustion one probably wouldn't work out so well either.
Right. Like, so if I ask it something like this, let's try it now. If we say, okay, my kid has failed math class, right? What could I use to motivate him? So look at that. The roots of education are bitter, but the fruit is sweet, right?
Sodom. Yeah.
Failure is simply an opportunity to begin again. This time more intelligently, right? I've not failed. I found 10,000 ways that don't work, right?
Oh yeah. I know that'd be a hard one to like not be like, well, like if your kid comes back with you on that, it'd be like, whew, that's a good quote right there, right?
Right. Anyway, this is like, okay, so let's actually look at the code that's actually used to do this, because that really teaches you how this embedding works to do what's called a semantic search, trying to find things that are close to each other in meaning from the human perspective, like what it means to people, right? It's not a search where it's like all the characters are the same. Okay, so if we look through this code, I've got this array of strings, and what I do is I go and I take all of the quotes that are in the list of quotes up here. Okay, this is my list of quotes.
Right.
And I simply then create a quote object just because I want to know the original text. And then I call the embedding model and I compute what the vectors are. So if you look at this Java object, I simply have a string and the associated embedding. That's it. The quote and the embedding that the quote belongs to. So going back to the code down here. So now when a question comes in, which comes into this guy here over an input, like this is the the query parameter that we sent, like the topic.
Right.
So that topic is then, what we do is we calculate the embedding on it. So we get the 1,536 points that are
Right.
part of that vector. And then what I'm doing is I'm taking the list of codes, code objects, and I take each code and I say to it, great, here's the topic text. Here's the embedding that goes with it, the embedding text. And I would like you to calculate a cosine similarity between the code and the question,
Mm-hmm.
and compute that one number. And then I say sort that list, and then I just return the top three.
Nice.
Okay, so if I was to hypothetically just return the whole list, just take that out. Maybe this will explain better what's happening. So when I ran it here, you can see that it basically said, hey, this is the topic I'm searching for. This is the B item. This was the similarity score.
Right.
But the fact that it was 0.7, should it have been a 0.9? I don't know. It doesn't matter. What matters is that out of all the 25 items, right, these were the top three matches.
Yes.
So if I go back here to my app, because I changed the code, I need to rerun that app. All right, let's take this and try again. Okay, now I should actually get 25 responses back. And those 25 responses are, you can see them right here.
Yeah, all different scores. Yeah.
Yes, all have different scores. And so that is how you do a similarity search, a semantic similarity search. And imagine that I didn't have 25 codes, but I had 1 million rows in the database.
Right.
Oh, that is going to be a lot of calculations.
Right. Right. Yeah.
Because you have to calculate like the comparison against 1 million rows.
Mm-hmm.
So generally speaking, this type of vector search, while the math is known, it's very computationally intensive. And so that's why people tend to also use a vector database alongside the application when you're building these AI-powered apps, when you need to do a semantic search. Because the vector databases have shortcuts they use for being able to do the search quickly, indexes and all of that. Now, what vector database to use doesn't matter to us because we're using Spring AI, and Spring AI supports all vector databases. Okay. I hope this is making sense to folks on the value of what is a what this means. Okay, so now that we know what the values we can do a similarity search, what happens if we have some files and we would like to try to basically embed them, right?
Right. Right.
So within the data project here, I've got some files that we can play with.
So this is going to be like, hey, take these files, like AKA my own corporate data, and then maybe store these embeddings so that we can do more appropriate chat responses, right?
Yes. So for example, there's Shakespeare.txt. I'm not going to open it because it's going to make IntelliJ unhappy. This is all of the works of Shakespeare.
Okay.
So it's like 10 megabytes.
Oh, wow. Yeah, that's a lot.
Yeah, in here, I have a fake database of like a JSON file with a bunch of bike product descriptions. Okay. In here, I have the same bike data, but this time it's like kind of like documents, like a PDF. Like to imagine it's like a product spec sheet, right?
It's starting to look familiar.
Yeah,
I've seen some of these files before in Acme Fitness.
Yeah. This one is my favorite. This is the City of Toronto fence bylaw, which is basically tells you how high can your fence be, what things, how close to the street can you be, like you have a pool, you must have a fence, right? Like if you have a deck, like all this type of stuff. And so the idea is when you want to do like interesting applications, you need to vectorize your corporate data.
Right.
That's really the insight. And the question is, how do we do that? And the answer is Spring AI gives us ways to help us with that. So what I've got here, let's start with this code here, where what I'm going to do is I'm going to try to vectorize the works of Shakespeare. And you can see that I get an error message that the request is too large. Okay, and it tells me that, I've requested too much stuff. Go away.
Tokens per minute.
Well, it's also too, I also exceeded the size.
Okay.
Okay. So what will happen is you're writing your code, you want to vectorize your corporate data. You don't want to think about oh, for this embedding model, I need to, this is the maximum size. Am I above, below? So there's this idea of chunking. Okay. And so to vectorize the works of Shakespeare, what we do is we start by creating a token text splitter. And this time I take that whole entire Java string with all the works of Shakespeare, all 10 megs, and I create a document, and then I tell it to split this document into a list. So it's going to split it for me. And then I'm going to just save myself time. I'm going to only calculate the embedding on the chunks. So I take the big document, the big file, I chunk it up into small pieces. And that is the idea of setting up a chunk. So it's telling me here that the file was split into 1,847 chunks. And now I calculated 3 embeddings because I don't want to waste my money. And I just did 3 of them to show the example. Does this make sense?
Yeah. And Nevin posted a little bit earlier about the 1536 is related to the embedding vector for text embedding 3 small. Large has a higher dimension count, I guess, on the embeddings. And I guess with here, you're saying, all right, my Shakespeare's huge. The stock's way, I gotta split this thing up to fit in whatever size I have available.
Exactly.
Gotcha.
And that's what you would take and you would store in the database. We're gonna see a little bit later how we're going to use all those chunks to answer interesting questions, right?
Okay.
But I want people to know, what can Spring AI do for me to help me with this? Okay, so we learned now how to do this. So now let's deal with, so Shakespeare was a text file. That's kind of interesting. What happens when you have structured data, right? So for example, I have let's go back here to the bike specification. So I've got all of this information here. Now, if I'm calculating the vector embedding, I don't necessarily want to use the word to pass in all this information. Maybe I just want a subset of the data. I don't want the tags as an example, right? In the vectorization. So Spring AI allows me to use what's called a document reader. And you can see here for this document reader, I told it I want you to read the bikes file. This is just the path to the file. And then I said, I want you to pull out from each JSON object the name, the price, the short description, and the description. Those are the fields I want you to pull out. And I want you to convert that into a list of documents. So this thing here now has, for each JSON object that was in the file, now I have a document which has the concatenated text, okay? And now I can take one of those documents and I can calculate its embedding.
I see.
So I'm setting up a data pipeline to do this. So let's actually see what happened here. Okay, so let's look at the output that we got. Okay. So you can see it parsed the JSON file and it found 25 JSON objects. So it created 25 documents. And then each of the embeddings would have 1,536 dimensions because that's the embedding model we're using.
Okay.
It assigned each document a unique UUID. So it would have a document ID that you could then insert into a database.
Okay.
And there's no metadata. Well, this one is printing out the pointer to the array. We'll ignore that for a second. And so this is an example of what, like this line here produced this text. So you can see it says name, adrenaline, price, $14.99, short description, and then description, colon, all of this. So this text here was made by Spring AI. And that is the string that was sent to the embedding model to get back the embedding. Does that make sense?
Yeah, yeah. And then you would save this in this, like the vector store, and call it later if needed.
Yeah, yeah. This is just showing you that, like, no matter what your data source is, Spring AI can help you. And the most likely data sources you're going to encounter as a developer, in my opinion, are 3 types of data sources. Text, obviously.
Right.
2 is going to be JSON, right?
Mm-hmm.
Because maybe you pulled something from a database or you got a message. 3 are PDFs.
Oh, yeah.
Okay.
Yeah, probably a lot of PDFs out there sitting around.
Yes, sure. Yes. So let's actually take a look at how we deal with that. Okay. So the way you deal with that is there is a PDF document reader.
Mm-hmm.
And what I'm doing here is I'm telling it, go ahead, open up the bylaw, the City of Toronto bylaw, and I would like you to extract the pages from that. So you can see here with page extracted text formatter. So take each page in the PDF and turn it into a document. And you know how like PDFs will typically like have a copyright notice at the bottom, page numbers. Mm-hmm. That information is not very useful. Right. Okay. So I'm telling it to delete the bottom 3 lines of the PDF of each page. Okay. And then usually your PDF might have like a fancy title page with a title and a graphic. And I'm like, well, I don't need that information polluting my database, so skip the first page.
Gotcha.
Right? And then it says take each page and turn it into a single document. Okay. And now I get, again, when I call pdfreader.get, I get that PDF has been turned into a list of documents, and I can calculate the embedding on that document.
Nice.
Okay, so let's actually now try PDF pages. And that's an example of, let's see, what did it do? So the input was the bylaw.pdf file. Mm-hmm. And it gave it a document ID. And then you can see alongside of it, there was like metadata attached to it, because now I know like this particular document came from page number 1 from the file called bylaw.pdf.
Okay.
And alongside the document, there's 18 bits of document metadata. Like it'll keep the page name, bunch of stuff, so you can tell where this came. And then this is showing you the first document that Spring AI extracted. You see Toronto Municipal Code, Chapter 447, fences, right?
Yeah.
It's giving you like the information that was in the fence bylaw, right?
Nice. I mean, it looks like thrilling content.
I know. Yeah. But like that's what you're going to be doing. It's going to be
right.
Like,
yeah.
You're vectorizing the insurance policies at the insurance company. So because you want to write an app where you can ask it a question like, how much am I covered? When is my renewal? Right? All this type of stuff, right? And so that is kind of what we have in here. Now, there's other ways. Like you can see this one is chunking up the PDF file by paragraph rather than chunking it up by page, right? Because maybe the pages are too big or whatever. Like there's lots of strategies for doing this. But in this case, let me see, does it tell me how many? Yeah, it didn't tell me. That's probably like hundreds of paragraphs or thousands in this case. So now that we know, like we can calculate an embedding, we can get a vector, we can compute if 2 vectors are similar to each other. Then the next question is we learn how to take any input, whether it's PDF or JSON or text, and we can, using the power of Spring AI, we can chunk it up so it fits within the limits of what the embedding model can do, and we can easily calculate the embeddings. So the next step is we need to store those vectors somewhere.
Right. Right.
And that is where we find that Spring AI has an abstraction that we can use called vector store. So if we go here into the vector store, what you'll discover is that, well, it says right there, vector store, right? And what can I do with a vector store? Well, I can add a list of documents to it.
Okay.
I can delete some items from it, and I can search it. I can ask it to perform a similarity search.
Oh, nice.
And the cool thing about it is that there are many different vector stores out there. Like you can use Postgres, you can use Python, you can use MongoDB, you can use Oracle, you can use whatever. So as a developer, they all have like different APIs. And instead of me having to learn the API for Pinecone, then go learn the API for Cosmos DB, then go learn the API for Postgres, I simply ask Spring AI to give me a vector store. And I can take that vector store and I can store stuff in there. And it will do the right thing. So if I take this one here, and let's call load, right? So let's look at the code that's happening. I'm, again, taking my bike's JSON specification. I'm getting a list of documents. But this time, I don't call the embedding model. I just basically say vector store.add, and I give it the list of documents, and it knows before it adds it, it needs to actually call the embedding model to calculate the number of vectors, and it inserts it into the database.
Oh.
And so I can switch from a Postgres to a Mongo to a Redis to an Oracle to a Pinecone, and I don't need to touch my code.
I see. So we're kind of taking the raw data, cleaning it up, and then preparing it to then load here.
Yes.
And then once it's loaded, then I'm assuming that we can call it after the fact. So like you mentioned the similarity search, that's essentially the vector store itself is doing that processing, right?
Yes. So the code before where I had like go and call it the cosine similarity. Now that code, if I call the query here, you can see this vector store similarity search topic, right? And it's going to give me the top matches. Now, is it going to give me the top 3, the top 4? I didn't pass any extra options to the similarity search, so I get the top 4.
Oh, I see.
That's the default setting. But I could have told it, give me top 10, top 5, top 2, top 3, whatever. And the really brilliant part about it is that, like, remember how we talked about you have to compute the topics, embedding, and then calculate the similarity for each row in the database. What if my database has 1 million items in it? I don't want to do millions of calculations. And each database vendor has like tricks and hints and various things it does to speed stuff up. Right. And they're unique to that type of vector store. This makes sure that all of those shortcuts are being taken without me having to know what they are.
Right.
Okay? So that's the value that I get. So if I go here and query it, let's see what it comes back with. I asked it, let's see, what did we ask it? Was the default. Which bikes have extra long range? And it went and told us Sonic Ride, Agile Eon, Fast Rider, and Swift Bolt, right?
Ah, nice. Yeah, so it's going to this.
It's like did it actually like it's like in meaning, what it found is that when the meaning of the question, which bikes have extra long range, documents that seem to have the most value, the closest in meaning to this, were these guys right here.
Now, and is this really even calling an LLM at this point, or is this just all within the vector store?
There's no LLM involved. There's an embedding model, which doesn't have to be an LLM, and just a vector database, a vector store in this case. In this case, the vector store that I'm using is the simple vector store, which is just an in-memory one that is implemented by Spring AI, just if you don't have a vector store. And if I go and I change a setting in my app, which I don't want to do right now because we're going to run out of time, I can make it use pgvector or Pinecone or whatever. Okay.
Gotcha.
So again, in the spirit of sticking to what the concepts are, I think this hopefully gives a sense of what is a vector store. Okay.
Right. Exactly.
All right. So now that we know what a vector store is, we are ready now to learn the next pattern. So for that, we're going to go to the pattern called stuff the prompt. And now that once we know what stuffing the prompt is, we're going to be able to combine it with embeddings, and that will give us RAG.
Mm-hmm.
So let's look at this guy here. So in this example, we have a document, which is a question. This is about the Wikipedia Winter 2022 Olympics, something like this, right?
Okay.
And then we have a prompt. And when you ask the model a question about information that isn't part of its training, let's say you're asking a question about the insurance policy Adib has with his car insurance company. Well, obviously, the model doesn't have my insurance policy as part of its training data set. So I can't ask it specific questions about my insurance policy, like when does Adib's insurance policy expires. But if I had a copy of the text of Adib's insurance policy, right, I can copy and paste that into the prompt, and I can ask a question about it. I can say, using the following pieces of context, answer the question at the end, like whatever this thing here, and then say, if you don't know the answer, just say you don't know. Don't try to make up an answer, right? Yeah. That's the prompt. So now I'm basically saying, I'm going to insert into this text the context here, and then the question, and then it's supposed to kind of produce the helpful answer at the end, right?
Right.
So in this case, I'm wanting it to answer the question, which athletes won the mixed double gold medal in curling in the 2022 Winter Olympics? Mm-hmm. And the way that we're taking it is we're taking that template, which I was just showing here, right? We're reading it, and that template had it had two pieces of information I needed to populate. One was the question that the user asked, which is this one here. Right. And one was the actual document, the content. And then once I have that template, I can actually call the chat model and like kind of produce a result. Okay. Mm-hmm. So let's try that out. Let's open up the stuffing request, and we'll send it. And it tells us the names of the winners, right? Mm-hmm. But this information came from this Wikipedia article.
Prompts, yeah.
Okay. So stuffing the prompt is the idea of is basically telling the model, hey, I don't want you to answer a question based on the training data that you received. I want you to answer a question about something specific that's in here.
Right. Yeah.
And that's what makes the answers more accurate.
Otherwise, they'll just
it could hallucinate.
Yeah. And yeah, that please don't make something up. That's definitely a key story there too.
Right. So let's just close these out here for a second, and let's now go to the retrieval augmented generation section. So in here, what I'm going to start with, I want to ask questions about those bike specs, right? Like I want to build a helpful assistant which answers questions about these e-bikes. And let's go here and first let's load it. All right. And let's now, once it's done, we'll send a query. Okay, so it took the 25 bikes, it put it in the vector database. Now I'm going to run a query, and then we'll explain what the code is doing here.
Okay.
So first, when I take a query, I'm asking which bike has extra long range, right? Mm-hmm. That's my question. So I go to my vector store and I say, find me the top documents in the vector store which are related in meaning to this user's question. And then once you have that, what I want to do is I'm going to then give it to the LLM. So first now I got the list of documents. So let's look at the prompt. So I create a chat client, I create a prompt, and I tell it, you're a helpful bike assistant at a bike store. Your job is to answer customer questions about e-bikes that we're selling. The question should be answered based on the provided bike specifications. If you don't know the answer, politely tell the customer you don't know the answer. Then ask the customer a follow-up question to try and clarify the question they're asking, right?
Right.
So that is the system prompt. Mm-hmm. And then now, what is the user prompt? So now look at the structure of it. So I basically say, answer the question in the question section. So you can see here, I put the beginning of the question, like the end of the question, and in here, I'm going to insert whatever came in as a question.
Right.
And then same thing with the context, based on the context in the context section, right? Right here. Use the information here. So now that I have that, I'm able to pass the topic that was what would have been typed in the chatbot, and I'm able to pass in the bike specifications. And where did the bike specifications come from? They came from the vector store.
Right. Oh yes, I mean this is kind of very similar to how the Spring Metal app works too, right?
Pretty much. Yeah. This is exactly how the Spring Metal app works. And so, and then I basically call the model, the LLM, and I get. So you can see that the response it came back wasn't like hey, these are the records I found in the database. It basically said the bikes that have extra long range are Sonic Ride 8S. This bike is equipped with 625 watt-hour battery, right? The model, this one has another so it looks like all the bikes that have 625 watt-hour batteries are have extra long range, right? So give me a little summary of the product. And looks like this one here has an option for a range boost, extra battery with 500 watt-hours.
Oh, wow. Another one.
Right, yeah. So, but this is this idea of step one, search the vector store to find the context. Step two, stuff the context into the prompt with the user's question to then generate. That's why it's called retrieval augmented generation.
Right. So yeah, you're pulling from your vector store, you're stuffing the prompt, and then basically feeding this new information to make a better generated response, I suppose.
Yeah, that's exactly right. So the basics of this are like, hey, this doesn't look so hard to do, but can we actually do better? And the answer is yes, we can.
Okay.
So what can we do better? Well, we can write less code. So one of the cool features in Spring AI is this concept of advisor. So in the previous example, like I had to write a lot of code to say, please go, and this is the system prompt and all of this. But Spring AI has something called a question answer advisor, which is like a canned implementation of a retrieval augmented generation. So now I pass this guy the question of, here's the vector store that you should look up the documents in. Here is the like top 5, like this where I can set search request parameters, like look up the top 5. And then this is the kind of a little bit of a like, hey, here's what you should do. This is kind of giving it a prompt.
Right.
And that does the same thing. So the idea here is that you have lots of applications in your company where they're going to implement RAG. Instead of like writing the RAG algorithm multiple times in each application, you create a packaged implementation. Yes, you're capturing the pattern. So there's actually a more powerful version of this in Spring AI, which is called modular RAG, which I don't have an example of it here. But the concept I wanted to communicate is the idea of you can capture patterns for AI applications with Spring AI, and you can reuse those patterns across multiple applications. They're called advisors.
Nice. Yeah. So, as these things are becoming more popular, like the big benefit of Spring AI is like kind of figuring out a lot of this for everybody, and you can just kind of use that implementation to get started at least.
Right. Yeah. Because like, let's say you're the bank, and the bank wants to add AI to 100 applications in the bank.
Right.
Each of those applications like might implement a pattern, and instead of every developer needing to know how to implement that pattern, they can use it. Like no one in Java goes and implements their own list object, because you have like array list and linked list and blah 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 available for you, and you can just use those. And that's hugely valuable because they get debugged in one place, they're reliable, they're tested, all that. Right?
Yeah.
So now that we know what retrieval augmented generation is, we've really learned how, like, we built it up from an embedding is a bunch of numbers. We can compare how close to embedding vectors are using cosine similarity. And that lets us do semantic search. We can then take the semantic search and we can run it at scale against a vector database, so we don't have to waste our compute resources.
Right.
That allows us to then build pipelines to take corporate data, vectorize it, put it in a database. Then we are able to write applications where we can search through the vector store to find the relevant context, use that to combine it with the user's question, and then produce an output. And Spring AI lets us capture that whole entire pattern end to end.
Yeah, that's pretty incredible to see how really how little code's really happening here to do all that.
Yeah.
I guess all that magic, so to speak. Yeah.
So
Yeah.
we have like 4 minutes left. So I'm going to very briefly talk about agents for 4 minutes. And then in the future, perhaps we can do like follow-up that I could do a little bit more deeper dive on how to build agents with Spring AI.
Yeah, sounds great.
Okay, let's take a look at a, let me actually do this one here. All right, let's do this. Okay, so I'm going to run it because this one takes a little bit of time to run, a couple of minutes.
Okay.
So what I have here is I have what's called a self-reflection agent. And self-reflection agent is one where you have like, let me tell you what the agent does. So this agent does my least favorite task ever. You put a presentation somewhere and they ask you for a bio.
Yeah.
Writing a bio is always like an absolute utter pain, right?
Yeah.
So this profile.pdf is when you go to LinkedIn, you click and you can download your profile as a PDF file.
Oh, I didn't know that, but I mean that's a pro tip right there.
Right. So what I did is I wanted to write an agent that takes a LinkedIn profile PDF and creates a bio. Okay. All right. And the idea is in here is that there's a writer and a critic.
Okay.
And what it does is when you invoke it, it's going to basically, let's actually look at the controller. So this is where my PDF is, and I can say, okay, I would like to do 3 iterations of writer and critic. So self-reflection agent, write me. Here's the profile, and I go 3 times. So if I go to write here, what it's doing is it's saying, I'm going to go to the writer, and I'm going to ask it to make a bio.
Okay.
And then I'm going to iterate a couple more times, and I'm going to ask the critic to provide feedback. Here's the original LinkedIn. Here's the bio. Give me feedback on how well this bio is. And then I take that feedback and I go back to the writer and I tell it to revise its original bio based on the feedback from the critic.
Wow.
Okay, so that's what's happening here.
Okay.
Let's actually see what's going on in the writer.
Oh, okay.
This really just becomes like prompt engineering.
Right.
So I'm telling it like, okay, I'm creating a chat client to represent the writer. And I'm telling it you're a friendly expert writer who helps professionals create impactful biographies that are easy to understand, exciting. Oh, I guess I have a spelling mistake here. And show the brilliance of the professional. You take pride in short, memorable biographies you come up with. Right?
So this is such a serious prompt. I love it.
I know. The biography is written based on the professional's work experience provided to you with a LinkedIn profile. The biography is targeted at peer professionals in the same industry as the subject of the biography. And I also tell it that it's really good at taking feedback and it can apply that feedback, right?
Nice, yeah.
Okay. So now all you have to do is when you call it and you tell it to write a biography, right? I just basically say, well, give me the LinkedIn profile content as a string. And you know how we had PDFs, and earlier I showed how you can turn a PDF document into a string, right?
Right.
So I use that feature of Spring AI. So now it says, write a 1-paragraph professional biography suitable for the conference presentation based on the content below. So then, and I inject the profile, right?
Okay, yeah.
And then when I ask it to revise, I basically say, look, here's a bio that's been written by someone. I don't tell it was the one that wrote it. It doesn't matter. Here's the feedback about it, right? And here's the actual original profile from LinkedIn. And then what I want to do is I want to improve the biography so that it's a single paragraph with a maximum of 125 words. Which
Okay.
usually it gets very wordy when
Yes. Yeah.
you do the original one, right?
Right.
And then if you look down here at the critic, and the critic, the prompt is, you're an expert marketer who helps clients improve the quality of their communications, right?
Right. Yeah.
Your goal is to get rid of all fluff and focus on what truly matters to the target audience, right?
Whoa. We had fluff. Get rid of the fluff and marketer. I'm confused.
Yeah.
But yeah.
It's like going to go into like
But like your job is to add the most fluff as possible.
right, but like that's gonna melt the GPUs of the model with the prediction, right?
Uh-huh.
So it's like, hey, you provide clear feedback on how to make written content more impactful for the target audience to help accomplish the objective. Okay, fine. But now I just basically say, please analyze the bio. Here's the original profile, and write some feedback. And so it's this like constant kind of fight between these two, where the writer writes something, the critic criticizes it, and just to recall to everybody, it's going to do it 3 times.
Oh, okay.
That's what we told it to iterate 3 times.
Yeah.
So let's look at what it produced in my case, right? So you can see here, the first one. I mean, you'd have to kind of read it to see if it was actually kind of becoming better in the iterations. And when I played with it in the past and looked at it, it was actually getting better. So again, is this like something that you need to do in your app? I don't know, right? But it illustrates, the code here illustrates the mechanics of how you can leverage Spring AI to build an agent that implements the self-reflection pattern. There are many other patterns that one can use to implement agents, and there's some really nice proc posts by Christian on the Spring IO website that kind of explains what some of those patterns are, and we're working to. I think what you'll find is that over time, all these will become like more kind of by default implemented in Spring AI. But Spring AI already today is like ridiculously useful for building agents. So I consider Spring AI to be an agentic framework, an agent framework for Java developers to build AI agents.
But I think it's a great tool. Sorry, I didn't mean to cut you off, but I think it's definitely a great tool to really just like to have there's a ton of Java developers out there, right? And like I've seen this kind of firsthand over over the past year and a half now. Is basically getting all these developers to be empowered to do this really kind of, I would say, maybe more cutting edge, advanced type of development without, as you say, really being, data scientists or really math experts, so to speak, too. So I really like to see where this is progressing. And, this first part 1 was about 6 months ago. We just did part 2. I'm really curious to what part 3 is going to look like. I think in between the 2 parts, we had this thing called the model context protocol come out. And, a bunch of other things. So,
yeah, there's a huge amount of stuff that one can cover with Spring AI. But just to wrap it up, just a thought for anybody that's watching that's a developer. Look, the value that you have as a developer in the age of AI is that you have an understanding of the business that you work in. You have subject matter expertise, the domain specific expertise. And in order for your company to get an ROI on an investment in AI, you as that developer who knows the existing apps are best positioned to add AI capabilities to those apps. And that's going to help your company make more money, and it's going to make you more valuable. So with that, that's it. That's all I got for you today.
Yeah, well said. Well, thanks for coming on the show again today. Thanks to everyone who's watching live. If you want to learn more about this, just a few episodes back, we had Corby and Kurti on where we kind of dove into the model context protocol. So if you like what you saw here, you'll probably like that episode as well. And then, always we have episode 26 if you want to go way back in time and watch the first part of this. But we'll do our customary. You should don't forget to like and subscribe if you like what you see here. Stay up to date on all the Cloud Foundry weekly happenings. Our YouTube channel. If you like the long form audio, we have cloudfoundryweekly.com too. You can grab us on all your podcast things as well. So I guess without further ado, thanks for coming on, and we'll sign off here. So any other last comments here, Adib, or are you good to go?
I'm good to go. Thanks, everyone.
All right, perfect. All right, 3, 2, 1. CF bye.
Okay.